Good evening, everyone. And my name is Mary Burke, and I want to talk to you tonight about nature-based solutions to flood management, particularly in the Clonmany area of Inishowen. So I think it would be useful to start by just going back over what exactly is nature-based solutions to flooding. What we are trying to do is restore and enhance natural catchment processes. These are the ways in which catchments naturally behave, but that because of our use of land, we have changed those and interrupted those processes so they are no longer behaving in a way that is most efficient to solve many of the environmental issues that we are faced with today. So, a really interesting and valid question is, well, why do we need a nature-based solution? Why can't we use the tried and tested practices of hard engineering, which have been shown to hold floods within large concrete walls within towns and villages for hundreds of years? There are a myriad of reasons. There is the cost, whether or not they're still effective under a changing climate. There is the aesthetics of them. However, right now I'm just going to focus in on two reasons. The first reason I'm going to focus in on is around the types of floods that we experience in Ireland. We are used to, particularly in Inishowen, of these many days of rainfall. It can be light or heavy, but it goes on in long duration rainfall events. And this leads to a condition where we saturate our soils entirely. And when the capacity of the soil is filled up and it can no longer absorb any more rainfall, you get what's known as saturation excess overland flow, which is the beginning of floods. And this is exactly what happened during the 2017 event, where a very wet August, combined with lower temperatures to reduce the efficiency of drying out of any soil, was followed by an extreme rainfall event. And that led to rapid runoff of rain, and it led to the extreme flooding that you experienced at that time. So what you know and have seen and experienced in terms of very wet soils in the winter and spring in particular has now been analysed by scientists across Europe, including scientists from Ireland. We've looked at our own rainfall records. And what they've shown is that we are now experiencing wetter soils earlier on in the season, up to 14 days earlier in the season. We're getting this maximum moisture in soils. And this is shown in particular on this map here of Ireland. You can see that the north of Ireland and the east coast of Ireland are particularly susceptible to these earlier onset of wet conditions. And the rest of Ireland, the west coast and south, you can see is blue in colour, and that's showing that the saturation conditions happen up to 2 weeks later. So regardless of where we are in Ireland, what we are looking at is a much longer flood period over the autumn, winter and spring. And so you're looking at a higher likelihood of being subjected to floods in Ireland today. So what's important to realise is the floods can be of various different magnitudes. They don't all have to be as large as the one in 2017 to bring inconvenience and cost and loss of livelihood to Irish citizens. So there's a term that's used which is talking about nuisance floods. And these are floods that happen more frequently. They are lower magnitude than the real extreme ones that we have all experienced. But if you sum up the cost of each of these more frequent lower magnitude floods, it actually turns out to be more expensive than the 1% flood or the 1 in 100 year event. So the second reason that I want to put to you why we need a nature-based solution is provided at the end of this paragraph written about the town of Clonmany by the Office of Public Works and published in 2018. And I'll just bring your eyes down to the bottom of this large text, where it says that due to the small numbers of receptors affected within Clonmany, it has been agreed as a low or no risk area for further action. And therefore, the existing maintenance regime should continue in order to maintain the current standard operating plan. So nothing's going to happen in Clonmany to assist in mitigating the effects of the floods. It's important to remember that nothing can prevent flooding. Flooding is a natural process and we will all be subject to continued flooding. So what we are talking about tonight is increasing our resilience. And we are proposing that nature-based solutions combined with property flood resilience together will be part of an effective approach to mitigating the effects that you will feel due to flooding in the future. So let's talk now about how nature-based solutions actually work. We are looking to slow the flow. We are looking to keep the water in the landscape a little bit longer, no more than 24 hours, and certainly it turns out to be between 6 and 12 hours. What we are not looking to do is flood farmland. So how we do this is by, first of all, considering an entire catchment as one unit, from the mountains down to the floodplains, through the villages and towns and out to sea. It is one unit, and we implement a very, very large number of small measures throughout this whole catchment. Now, if you look at the diagram on the left, it can be that we can plant new trees. We can put in structures that are known as leaky dams that are made of large woody debris. We can utilise and reconnect rivers to their own floodplains. We can mitigate floods, but we can also improve water quality by stopping the sediment running off land, arable land, into the stream and destroying the aquatic environment. So that all sounds quite acceptable, really, in terms of working with nature and improving nature. But a valid question is, does it work? So because the area of looking at nature-based solutions for mitigating floods is relatively new, there are only a handful of studies out there that have actually implemented them and had time to monitor whether or not they're successful. So I want to introduce you to the town of Stroud in the UK, in the southwest, and I'm going to show you a few pictures, images of floods that they have received in 2007 and 2012. And some of these will be quite familiar to you in thinking and remembering the flood of 2017. So here's an aerial shot where you can see that the town is actually isolated. All of its main infrastructure networks have been cut off from the rest of England. Although the population of Stroud is significantly larger than Clonmany, it is similar in that it's located at the confluence of several rivers that are a similar size to those that are coming into Clonmany. And we can see some of the effects of the floods, repeated effects that they were subjected to. So local shops were inundated and stock was destroyed. Local residents were caught completely by surprise, either driving along, carrying on with their business, or parked cars were physically moved and washed down streets. And of course, local amenities and parks were inundated not only with water, but with sediment and debris and everything that had been washed down from the upstream reaches, wreaking havoc on the town of Stroud. Clearly, the community was absolutely devastated and needed time to recover. But in subsequent discussions, for many, many reasons, the hard engineering protection was deemed to be not a viable option. So the local community got together and they proposed that they'd like to look into a nature-based solution and that these options should at least be considered. And they started to undertake a series of community walkovers, and they commissioned an additional catchment analysis, a scoping study, to see, what could be implemented and where should it be implemented. Following this scoping study, the community decided that they wanted measures delivered on the ground. They appointed a project officer who focused on working with quote-unquote sympathetic, environmentally minded landowners. And really the first stage was to develop and deliver a wide range of measures that would demonstrate and promote how these nature-based solutions could work. They were trying to build confidence and promote dialogue. So they implemented a series of measures, and we're just going to show you now what some of them look like. So these are known as large woody debris. They're basically native species of trees that extend right across small drainages, and they are put in either in an organized, layered way or in a more chaotic way. But the idea is that the water that flows into these will be slowed down temporarily. And that slowing can be a matter of 20 or 30 seconds. But if you have enough of these large woody debris dams, one after the other down a stream, they will serve to impact the rate at which the water during a flood reaches the main channel will be considerably slowed. Another feature that they installed are known in the UK as bunds, and these are composed of earth or wood, and they are low elongated mounds that are constructed in more open areas of the catchment, and they're like these small dams that will retain water for a certain period of time behind them, and they can be very, very low. They can be 30 centimetres up to half a metre. The taller ones you would put in maybe a little bit of piping to assist in the movement of water through them. But the ones that I've seen actually are grassed over and cattle graze on them, so they don't really interfere with the functioning of the agricultural functioning of the land on which they are built. By the end of what they call phase one of nature-based solutions implementation, they had built over 280 interventions. These large woody debris dams, these bunds, and other measures. And together, it's about 21% of the catchment now discharges through these measures, and that is distributed across 4 different tributaries that feed into the town of Stroud. So in order to answer the question of whether or not these nature-based solutions worked for the flood problem that the town of Stroud had, we would like a lot more data. We would like a much longer time series. So what I'm going to show you is not proof that it works, but it's an indication of the response of the catchment following the implementation of these measures. So the first thing I want you to see is that along the bottom line we have an axis that indicates time. 2 days. 2 days is 48 hours. And going up on the side, you have stage, which is basically the height of the water at a measuring station for this particular river. So it gets up to about just under 2 meters. And in 2012, you had a big rainfall event, and that resulted in a large flood. And that flood had a certain type of behavior, a certain hydrograph. It happened over a very short period of time, about 10 hours. It rose really quickly and it fell really quickly. And that's what caused the devastation of the flooding in the town of Stroud. In 2016, following the implementation of the nature-based solutions, the exact same gauge for a similar, not identical, but a similar rainfall had a very different response. On that occasion, the river did not reach a hazardous peak. It did not inundate and flood the town and land to the same extent, and it seems to have spread the flood curve over a much longer period of time. And so it's positive. It's a positive indication of the potential of these nature-based solutions. It's worth mentioning that nature-based solutions have the potential to mitigate flood hazards, but they also bring with them a large number of additional benefits. It can improve water quality. It can create and recreate habitats such as wetlands. It is effective in carbon sequestration. And in designing these features, you can create amenities for the local community to enjoy and occupy with their children, with their extended families when it's not raining. So if you're going to think about taking a nature-based solutions approach, a really important criteria is, well, how much does it cost? So let's go back and see how much it cost for the township of Stroud. So if we're looking here at a table that was published in an academic paper based on describing what the process that they went through. And they built 170 leaky dams. They stuffed gullies, which is similar to the leaky dams, just a little bit more disorganized. 6 of those. They built 15 bunds. They have culverts and grips. And they have, of course, they tracked and traced the costing of this, and it came to 38,000 English pounds, which is about 42,000 euro, which is a lot of money, but it's significantly cheaper than proposed hard engineering solutions. And in my opinion, that's attainable. So, as was mentioned earlier, I was part of a larger team that undertook an opportunity map. And that's a map that basically identifies in Inishowen locations where there may be opportunities for these nature-based approaches to mitigating floods. And we included one of the rivers that flow into the town of Clonmany in our study. So here is a map that shows you all of the different streams that we examined for our study. There are 4 of them that flow into Carndunna. We looked at the Crana River that flows into Buncrana, and we looked at the Ballyhallen River that flows into Clonmany. One of the difficulties that we share with the OPW is that there is a lack of river and rainfall records for this part of Ireland and for many parts of Ireland. And without that data, there's a lack of certainty about how the rivers are responding to rainfall. However, there is a subdiscipline in geography where we use local knowledge to help us recreate the response of landscapes to floods. And that's why this evening we really want you to embrace the opportunity of drawing on the maps that you've been given, the locations that you remember that floods happened and maybe when they happened. And we will look at that data and we will use that data in any future analysis. It's worth remembering that nature-based solutions to river flooding also benefit water quality. And if we look at the water quality for the rivers that are flowing into Clonmany, you can see that the EPA have assigned a poor status to most of those rivers. In our analysis of Inishowen and trying to identify areas that have good opportunities for the implementation of nature-based solutions, we looked at the land uses that currently are being implemented. And we can see that a lot of the upstream area of the rivers that drain into Clonmany are starting in the peatlands, in the bogs. There's also forests, there's also agricultural land. And all of these align with the potential to implement nature-based solutions. The height of the land is also quite important, and here you're just looking at the elevation of Inishowen, and you can see that there's some very, very high areas, over 600 meters in elevation, and in between them are some significantly lower areas. But perhaps what's more important when thinking about nature-based solutions, particularly for flood management, is the steepness of that land, the slope of that land. And ideally what we're looking for are slopes that are much, much lower. We're looking at slopes that will be between 3 to 5 degrees upwards to 15 degrees. And as you can see from this data here of the slope of the land on Inishowen, you can see a lot of it is bright and white, and they are showing very, very steep slopes. So it's important for us to be able to identify in detail where the lower slopes are, because that's where the opportunities are. So we undertook, first of all, an analysis using mapped data of the Ballyhallen River. And we followed up that analysis with a field visit where we drove and walked across a lot of the catchment to validate what we had originally mapped just using satellite data. The town of Clonmany has several large rivers that flow towards it and into it. And housing estates have been built right at what we call the confluence of rivers, where rivers meet. And this is known to be a location where there is a significant flood risk. But looking at the aerial photograph of this part of Clonmany, you can see that there is a significant amount of green space within these areas. And these can be thought of as potential storage areas for floodwaters that do eventually reach the township. If we examine the lay of the land, the slope, again in that same zoomed in area, we can see that the colour green and the colour white is showing us that the slopes are appropriate They're very, very amenable to adopting nature-based solutions. Perhaps a better location to think about nature-based solutions is away from the town and upstream in the headwaters of river systems. We've zoomed in here on three different approaches that could be implemented in the headwaters of the Ballyhallen River. To the left, you can see an elongated red polygon that surrounds the blue Ballyhallen River. That's a location where we think it could be considered to construct one of those earthen bunds that would slow the delivery of water in this part of the catchment. The second approach that we looked at was to see if the river today had shifted its location significantly from its ancient flow pathway, maybe that it occupied 300 years ago or so. And yes, there is evidence that the river course has changed, and that's very natural for rivers to do that. But it's also an opportunity that if during higher flows, those waters could be encouraged to reoccupy their older channels temporarily, again for 12 hours or so, that would slow the flow significantly on its path and on its journey down to Clonmany. The third location is that rectangular box in the top right-hand side, and that I want to show you just as a demonstration of a lot of the upland areas of Ireland and Inishowen where more organic rich soils, wetter soils have been drained. What we see here is an example of a type of drainage known as herringbone, and there's opportunities here to implement permeable barriers that would not wet the land. It would not defeat the purpose of putting in the drainage, but during rainfall it would slow down the flow coming into that central drainage area and eventually draining down into a tributary of the Ballyhallen River itself. If we look at the slope of the upstream area of the Ballyhallen catchment, again, we're looking at those white and green areas, and you can see there is a significant proportion of the upland catchment that would fall within those bounds of required lower slopes of between 3 and 15 degrees, where opportunities for nature-based solutions could be implemented. We've identified a few, but there are more that could be implemented in this area. So for Clonmany, our analysis of the Ballyhallen River, just as an example of one of the streams draining into the town, we have identified several areas where there are opportunities to think about implementing nature-based solutions. And these solutions we would propose would be effective in slowing down the flow that's reaching the town of Clonmany. There are many, many more opportunities in the Ballyhallen, and of course there are several opportunities yet to be identified in the other large tributaries draining into the town. But overall, Inishowen has demonstrated that it has significant opportunities for the implementation of a nature-based approach to floods. So thank you very much for your attention, and I'm now very happy to take any questions.